Function transformations. This will be a quick and dirty look without high detail. We're just looking at the concept. Parent function x squared looks like this. If we're going to add 2, if 2 is added on the outside of the parentheses, that means we're taking the original function and then those y values, we're going to add 2 to all the y values. So it's going to be shifted in the y direction plus 2. So this is shifted up 2. So we have 1, 2, and we redraw the same original function. F of x minus 3. We're going to take all the y values without any change to them. This is our parent function. We're taking all the y values, these are the x values that we're put into it, and we're going to subtract 3 from all of them. So it means everything is going to be shifted down 3 because it's shifted, we're subtracting 3 from all of them. Same shape. When it's inside the parentheses, before we evaluate this, before we get our y value, we're first going to add 4 to all of the x values. When we add 4 to that, this is going to shift everything to the left because it's compensating for that additional 4. So we're going to shift 3, 4 to the left. This is to the left 4. Conversely, when we have a -5 or a negative inside the parentheses like this, we're going to shift to the right, in this case 5 places. Let's look at some different things here. Negative x on the inside of the parentheses. This affects the x values. All of the positive x's are now negative x's. All the negative x's are now positive x's. But on our original function, this was symmetric about the y-axis. So this is still going to be symmetric about the y-axis because we haven't shifted left or right. We're just swapping all the x's and y's. But a unique thing about this function, not necessarily unique, but all of the values, -1 is +1. +1 is +1. -2 is +4. +2 is +4. It doesn't matter if we have a negative or positive in this x squared function. We're getting the same value out every single time. So switching the negatives, switching the x values for positive, negative, negative, positive, doesn't change the overall layout of this visually. Well, what if we have something like this, -x minus 2. This would be the same as the opposite of x plus 2, f of the opposite of x plus 2. Well, in this case, we're shifting to the left 2, and then we're going to switch all of the x values, positive for negative, negative for positive, which means that we're going to shift to the left 2, and then we're going to reflect it over that axis of symmetry, where this was also reflecting over the axis of symmetry. So we are not over the axis of symmetry, but over the y-axis. So we're shifting to the left 2, 1, 2, and then we are moving left, right. So it's a combination. It's a combination of the two. So we're shifting to the left, and then we are flipping over this y-axis. So it looks like this. Negative f of x. This is outside the parentheses, so it affects the y values. All the x's are normal, just all the y's change. So instead of a +1, it's a -1. Instead of a +4, it's a -4. So this just makes it opening downward. This is like y equals negative, or the opposite of x squared. Because when we have this, what we're really saying is this is the opposite of x squared. It's not negative x squared, but it's the opposite of x squared. We're taking that x squared and then we're applying the negative afterwards for our order of operations to be followed. All right, f of 1/2 x. We have, this is in the x direction, so all of the x's that we would originally put in, -2, -1, 0, 1, 2, 3, any number we can think of, we're going to then cut that in half and then square it. So this is going to really kind of shrink it this direction. We'll use a different color. It's going to shrink all of the x values, so it's going to look a little steeper. It's going to take longer for this to go to the right and the left, but it's still going to go up. It looks like it's going to go at a faster rate. If we have 2x, each one of the x's is doubled, and so it's going to spread that out like this. 1/2 f of x. Here we are taking all of the y values and cutting them in half. So if it was 1, now it's 1/2. If it was 4, now it's 2. If it was 9, now it's 4.5. It was 16, now it's 8. So it's going to squash that down, or squash that down. This one was spreading it out. Notice how these look the same. And they are. Here we're doubling all of the y values. So f of x, our original function, but then we're going to double all of the y values, which means that if it was 1, now it's 2. If it was 4, now it's 8. If it was 9, now it's 18. So it's going to increase at a much quicker pace. It's going to spread that out. Because it's outside the parentheses, it affects the y-axis. If it's inside the parentheses, it affects the x-axis. And that's true for all of these with function transformations.